So I'm going to talk a little bit about, what I like to call understanding understanding. One of the really challenges, oh, there you go, something's working. One of the big challenges I think for AI has always been my passion, is can we get computers to actually speak to us fluently, understand what we're talking about, and ultimately become our thought partners. Read stuff, understand that stuff, and ultimately understand it so well they can teach it to us. So ultimately, my ambition for AI is that we can democratize expertise, that machines act as objective, super-informed thought partners, providing expert and personalized, interactive, and explicable guidance, that they enable our creativity. Machines can read, understand, and teach, help us broaden our understanding, solve problems, and make more creative and informed decisions. They can share rational understanding, meaning machines help us logically sift through the noise, overcome our biases, not amplify them, and afford efficient access to traceable reason over world knowledge. Does that sound ambitious? Yeah, it's very ambitious. When I look at the AI today, which I'm fascinated by and impressed by, we have deep neural networks are sort of all the rage and are incredible. Object recognition, image recognition, voice recognition, control systems, interfaces to our neural systems, solving complex problems like playing Go. Of course, we use machine learning in Jeopardy pervasively. Even generating language and generating art. But one of the questions I want to tackle today is, in spite of this impressive work and the implications this has, not just on AI and moral society and everything we've been talking about, are we really at a point where machines understand? And can we ever get to that point? If you look at the EU's ethics guidelines for trustworthy AI, it's interesting to consider the things that come up in these guidelines, because they're almost tailored around the limitations and the issues we have with this type of AI we're creating with pure data-driven machine learning. Must it be understood? Can it be understood? So human agency and oversight. Humans should be able to intervene and oversee every decision. Technical robustness. AI should be secure, accurate, and not easily overcome by adversarial examples. Of course, privacy and data diversity systems should not be biased. They should not screw up our environment, our society. They should be accountable. But one of the kind of like central things is this idea of transparency, that the decisions made by these systems should be understood and traced by human beings. In other words, operators, humans, you and I, should be able to explain the decisions that they're making and how they're making those decisions. So that's a very high bar. And it's an interesting thing that we're struggling with today when we think about the AI we're creating. Are we creating an alien intelligence? Is it something, what happened to my computer? I don't know what happened. Who needs computers? I'm clueless. Can anybody help? I got nothing.
You're dark.
Huh? I'm dark.
You got charger?
Yeah, it was on 90%. Yeah, it's dead, actually. It needs a charger. There's one in there. There's one in my bag. So, now I'm pretty good at tap dancing. I can kick pretty high. Let's see, does that help? Is that, are we getting power out of that thing? Because it's not green. I feel like there's no power. So you want to ask questions? Anybody have any questions? Anything. Really.
Couldn't we hear a little about your company?
Yeah, sure.
That would be very interesting.
So I left IBM. So after the Watson thing, I left IBM. So we played the Jeopardy game. How many people saw the Jeopardy game? Watson played against Jeopardy. So we played the Jeopardy game in early 2011, and then IBM like turned Watson into a brand and started commercializing it. And I really wanted to kind of step back and think, wait a second. I mean, like a person who plays Jeopardy typically is a pretty smart person. But the reality is that machines still don't really understand language. And I just wanted to do the basic research. I wanted to go back to first grade. But all the rage was around the commercialization of the technology. So I ended up leaving IBM in 2012. And in 2015, I started Elemental Cognition for exactly that reason, as I wanted to go back basically and say, hey, how do we get computers to really understand language? How hard is that? And so, and what is it going to take to do that? And that's really what got me going with, I got to start this thing again. What got me going with Elemental Cognition, and hopefully when the slides come back, I'll be able to take you through that a little bit more. Good, so let's see. So you guys showing it now? So, so I want to talk a little bit about what we observe when we look at some of these deep learning systems and we look at the types of errors they make. It starts to make us think a little bit about, are they building an understanding that's compatible with human understanding? So how many people are familiar with the progress in ImageNet and the image recognition work? It's really phenomenal, right? So over the last several years, we've already beat humans at image recognition with deep neural networks. So you look at some 2011, they had an 8-layer neural network at a 26% error rate. If you look at this progress, by 2014-15, we're already beating, 2015 already beating humans with a 152-layer neural network, recognizing images better than more accurately than the best humans. Yet at the same time, these same neural networks will make this mistake. So they'll take the image on this is an adversarial example. They'll take an image on the Persian cat, image on the left, recognize that as a cat. Image on the right has been hacked. There's slight changes in it. You look at that image and you think, well, I still think that's a Persian cat. How many people think both are Persian cats? Yeah. So 98% sure the computer thinks that's a toaster on the right. So clearly the machine is building, this is just one silly example, one anecdotal example, but the point is the machine is building a different internal representation than you and I are building when we recognize those images. So is the AI understanding things quite differently than we're doing. Watson winning was a landmark in AI, but did it understand what it was reading? Does any AI out there understand what it's reading the way we expect it to? So this was a great Jeopardy question. U.S. history, Lincoln blogs, Treasury Secretary Chase just submitted this to me for the third time. Guess what, pal? This time I'm accepting it. Anybody have any idea? Right, so the answer is a resignation. So if you don't know the history, what you're doing is sort of using a language model. You're sitting there and saying, submitted what? What's the next likely word that would follow submitted? If I broaden the window, what's the next likely word that would follow submitted in the context of a president or a government official, right? So we're kind of processing it that way. So not only humans know things and reason about things, but they also use statistical language models. In fact, we asked this question to a 6th grade, and they didn't get it right, but they also used a language model. Their answer was a little bit different. It was friend request, but again, like they have a different context for what those words are, and their probabilistic guess for the next word was something different than resignation. Language models are getting incredibly powerful today, could string together beautifully sounding language. Does it make any sense? Do we understand it? Here's another question from the Jeopardy days. In cell division, mitosis splits the nucleus, and cytokinesis splits this liquid cushioning the nucleus. Anybody have any idea? So cytoplasm is the answer. But when we look at this, we think, when we see a machine do this, we think, oh, we project our understanding onto the machine, and we think, well, we got it right. It was 90% sure we're cytoplasm. This is actually, Watson's answer panel. Those are the top 3 answers. And we project onto it, and we think, oh, it has an understanding of cellular biology and physiology, and it has this rich understanding of all the different objects and relationships and can reason about them. Of course, that's just simply not the case. It was using, statistical patterns in the occurrence of words, matching words, doing synonyms and passage retrieval, and looking at hundreds of shallow linguistic features and weighing them using machine learning. That's what it was doing. But when we look at that intelligence, we think, well, what would have taken me to know that? And we project onto the computer. So this is really all about saying, if we want machines to work with us, to become our thought partners, and to really understand, that's actually a pretty difficult thing. How we ever even sat back and thought about how difficult understanding really is. When it really matters, in fact, we humans work very hard to understand each other. In fact, you could think about education, communication, journalism, science, art, mathematics, business management, marketing, advertising, really all forms of collaborative decision-making. Humans are investing a tremendous amount of effort just to understand each other. I look at you guys out there and I see some of you nodding, and I'm thinking, oh, they probably understand me. They're nodding. I have no idea if you understand me. It's not until we go back and forth, in fact, in a dialogue, and we test each other and we align our models, do we start to appreciate whether or not we're understanding. In fact, getting machines to learn how to develop a shared understanding might be the hardest and most important goal for AI. What is understanding? Well, first of all, it's social in some sense. It's a social artifact. We say we have an understanding. It's a model which explains our belief. Here is my understanding. I give you a model. I give you some model of what's going on in my head. It's dependent on shared prior models and communication. So how can I explain? Let me start with something we already understand. We build off of our common models to develop and build that understanding. So, and when we do that, like if you think about it, you engage in a conversation, you dialogue, and you go back and forth, and and in that process, you repair or you align your understanding until it reaches. In fact, there was some research on conversational dialogues, and in general, non-task dialogues, there was one repair was required for every turn, every conversational turn for 36 words. And somebody stopped and needed a clarification or a full correction or a complete reformulation. And you've been in conversations, you know that happens. In a task-oriented dialogue where there's more precision required, one repair, like one fix, one correction, one reformulation, was required for every 2.5 conversational turns, so about 20 words. So we sit there and we say, hey, we talk to each other, we understand. Actually, it's pretty hard to understand. We work a lot at it. And when we think, oh, a machine's going to look at all this corpus, do some statistical analysis, and it's going to understand, are we having realistic expectations of the AI? Here's a sentence: the ball went into the goal. Ball's got about conservatively 4 definitions. Went or go has about 40 definitions. Goal has about 5 definitions. Think of all the combinations. But you're probably landing on, it's probably a soccer ball. After all, this is the UK. Going into a goal, and someone probably kicking it with cleats on. You've built a mental model. We share that expectation. But there's another interpretation. The ball is a party. It's going into means starting to think about, and the goal is their common objective. That's a perfectly legitimate interpretation. In fact, the machine we're building at Elemental Cognition, when it does sentential interpretation, comes up with both of these interpretations. If you don't have any additional context, they're both equally probable. And there are more. A ball can go start thinking about a goal. Unlikely, because balls aren't sentient unless they're a cartoon or some sort. An entire party can dance its way into a giant goal. These are all possible interpretations, and it sort of depends on what your prior models are. The involving contexts are essential for consistently meaningful interpretations. So I want to go back to the first grade, and I want to give AI a real test. Can AI understand even a first grade reading comprehension test? So John and Mary were running a race. John fell, he hurt his knee. Mary looked back. Mary wanted to win. If she kept running, she would win. Mary stopped. She ran back. She helped John up. That's pretty basic. Who was running the race? Pretty easy, right? You look at this phrase, running the race, and you see what is the subject of that verb, John and Mary. Who wanted to win? Well, Mary wanted to win. I can match the phrase. Very simple to do. I could do text matching. Who hurt his knee? John. But did Mary win? Maybe. I'm guessing most of you think Mary didn't win. Was Mary nice? How old were John and Mary? You probably know their kids because they were adults. She wouldn't have gone back because she wanted to win the race. It would have been a whole different context. So context, language, prior knowledge, culture, reasoning are essential to understanding. Here's another story. I'm not going to read the whole thing, but it's about Fernando and Zoe, and they go to a plant sale. They buy some plants. Zoe's plant starts to wither, has to put it in the light, so forth and so on. Like, think about it. Like, to build an understanding, I, at minimum, have to know what are the agents, the goals, and their motivations. What's going on spatially? What's going on temporally? What are the cause and effect relationships that occur? And this actually gets kind of hard to do, and yet first graders can do this. So I took this state-of-the-art deep learning system that's used for answering questions of Wikipedia articles, and I turned it on to this first grade story, and I compared its performance to the Wikipedia type articles that was trained on to, again, look at the error analysis and say, where is it failing and how is it failing? So you don't have to read the thing, but here's the question: where were the scents produced? This is about the Indian head scent. And it actually correctly gets the United States Bureau of Mint. It's remarkable. It nails it. Gets that right? Now I give it the first grade reading comprehension, the first grade 5-sentence story there, and ask, where did Fernando and Zoe buy them implants? The answer is clearly, the plant sale. And it says, near a sunny window. Zoe puts her plant in a bedroom. That's just ridiculously wrong. So if a human was able to understand that Wikipedia article the way we imagine humans understand, then that same human should at least be able to understand a first grade reading comprehension test. So something very different is going on. Those of you who know about how some of these language models and neural networks work, you know exactly what's going on. They're looking for surface patterns in that text. They're not building a logical interpretation of the context. So wrong. Causality, why did the Mint look for alternatives? And masterfully, the neural network responds, the price of copper rose since gold became more abundant. That's correct. Of course, if you have a sharp eye for this, you can see in the sentence before there's a caused, and then we talk about something happening underneath. You could learn that the sentence after the one with the caused in it might be an answer to a why question without understanding a single word, right? Why does Fernando put his plants near a sunny window? The minty smell of the leaves was its answer. Just horribly, horribly wrong. Are we really moving toward understanding? And I think the answer is no. Here's the story again, and now I'm asking for one of the more advanced language model systems to generate the end of the story. The author's end was, soon both plants are green and healthy. I asked a bunch of humans on Mechanical Turk, and they answered this, they finished the story. Zoe's plants turn bright colors and grows taller and taller. Zoe's plant looks green and healthy. Zoe's plant begins to turn green and flourish. Her plants become greener and begin to look more healthy. Remarkable agreement amongst humans about what the next sentence is. The sophisticated language model answered, iced coffee comes out from beneath the leaves. The sun is still there, often the case, except maybe in London. The leaves of the herb turn bitter and dull, leaving her plants in a sad state. She's sitting with Fernando to warm her plant. So actually, this is kind of scary because these completions flow really well from a linguistic perspective, remarkably well, but completely demonstrate a lack of understanding of the story. So at Elemental Cognition, we're trying to build an AI that can acquire understanding and explain it well enough to eventually teach humans. Going back to my ambitions is to build an AI that ultimately can actually become a thought partner, can absorb enormous amounts of information, read it, understand it, and ultimately communicate it back to us and help us sift through that knowledge and apply that to be more productive and more creative. So I want to kind of show you, well, actually, I'm going to talk about a couple of the goals. Like the goals of the system at EC are, one, yes, to learn from big data, certainly, so learn autonomously from data and experience, but also learn from small data. Think about how humans learn. Take direct instruction about language and knowledge. Generalize. Produce plausible responses on unforeseen input. Communicate rationale. Humans should be able to understand why it's generating the answers it's generating, and it should introspect, meaning that the thinking that it goes through, whatever it's doing to come up with its answers, should be inspectable, understood, and corrected by humans. This is a very tall order. So this notion of embedding with humans and collaborating to understand things is a central approach that we take at EC. So iterative dialogue to build and align a shared understanding. So machine and computer work together to understand the same content. And there's a constant repairing. There's a constant alignment of their mutual understanding in that process. And when you look inside the system, we have deep learning, we have neural networks all over the place, but the architecture is far more robust in the sense that we have many pipelines for doing statistical sentential interpretation. We have symbolic and statistical reasoners. We have a pipeline of background knowledge building from the story all the way to generating knowledge graphs. We have a dialogue engine that pulls us all together and allows us to communicate with the human in a variety of ways. And you see this like this little cycle, thing here, and rather than a simple arrow. And the reason is because all these components are working in a sort of jointly, in the sense that as they try to build consistent interpretations, when they fail, they push back across all other components until they converge on a consistent interpretation. This is a very challenging thing. We've been at this for some number of years. We just got this thing kind of going. And I see if I can show you an example. So we have this notion that, like humans, the machine should learn through a curriculum. In other words, it builds and compounds understanding. It goes from one story to another story to another story. It learns and builds over those stories. So I'm going to read with it What Plants Need, which is a story about Fernando and Zoe. And I'm going to see if I could put this in big screen mode here. It's reading the story. It's doing what you can imagine, typical NLP pipeline. Lots of statistical techniques for doing that, of course. But it's also trying to build a logical and consistent interpretation of that story as it's going. And where it finds gaps or things that can't really tie together, it starts asking questions. So do you agree that Fernando and Zoe go to the plant store because they want to buy plants? I'm going to say yes. And you can actually kind of open it up and say, this goes to the introspection. You could go, it says, I'm guessing this because buying the plants is the next thing they do, so maybe this is their goal. So it's actually going through the story and saying, well, what kinds of things occur later in the story? Let me do that look ahead and try to figure out what might be the reason. So, okay, I think they want to buy the plants because they want them to be green. Is that right? So now it's looking for motivations, it's trying to pull that together. Not really. I mean, are they buying them because they want to be healthy? No. It says, now let's see, it's thinking, and it's probably actually struggling with the network. I guess I'm not really sure why Fernando and Zoe want to buy plants. Is it because they like the smell? And that's my best guess. And I'm looking, it says, I'm guessing this because liking the smell connects Fernando and Zoe to the plants, so maybe this motivates them to buy the plants. And so this is its reasoning. I'm going to say, yes, that's why they want to do it. So you have this notion of building an understanding, working with me to try to align it with its models, and now it's generalizing. I see it's generally true that if a person likes some property of a thing, then that can explain why they want to buy it. I'm going to say yes, that's a good generalization. And now what's it going to do now? I don't know. It's going to go slow. So now, it's basically banking that understanding. So thanks, I can use that when I try to understand other stories. And now it says, does it make sense that Fernando puts his plant in the window because he wants it to be healthy? So this is true. I'm looking at this, I'm saying, yeah, that's true. So I'm curious about why he's doing that. It says, if Fernando wants his plant to be healthy, then that could explain why he puts his plant in the window, because the sunny window has light and the plant needs light to be healthy. And where it's getting this information, it's actually going out to large corpus analysis, and it's trying to figure out, do windows have light? Light is mentioned in the story. Light's associated with the windows. Can I connect windows and light? If I can do that, I can start to stitch together this logic and explain what I'm understanding. I'm going to say, yeah, that makes sense to me. Thinking. Is it generally true that if somebody owns something, they want it to be in a good state? And I'm going to say yes. So again, it's taking in the knowledge, taking this, trying to generate. Now I can explain why Fernando puts the plant near the window. Fernando owns the plant and wants the plant to be healthy. This will happen if he puts the plant near the window because the window has light and the plant needs light. Is that a good explanation? It is. I can look inside and it tells me what it did. I made inferences from the story itself, like how the plant needs light in order to be healthy. I also learned what might be generally true by analyzing common phrases in large collections of text. For instance, this led me to believe that a sunny window has light. So I'm going to answer yes. So there's just a lot going on here, from the basic language interpretation to the abductive and deductive reasoning to the knowledge extraction from large corpora to tie all this kind of stuff together. I also want to know Fernando's location when he puts the plant by the window. I'm guessing he's still at the plant sale, but I'm not sure. So now it's looking for who are the agents, what are they doing, why are they doing it, where are they both in terms of space and time. So it's asking about the location. It can't quite figure this out. It's not sure. Is Fernando at the plant sale when he puts the plant by the window? Nope. And at this point, what we've created is an opportunity to actually, for it to ask me things, I could just type stuff in, like he's at home. And it's going to, as soon as it takes information, it's going to try to generalize from that information. Can you tell me how you knew that? And now what it's doing is formulating, based on its understanding of the story and based on what is extracted from large corpora, it starts to use a language model to ultimately construct possible explanations for what's going on. I see one that I like. Often when people buy a plant, they put the plant at home. And it's going to actually ultimately say thank you. It's going to bank that knowledge. So it's using the story to drive as much learning, as much generalization as it can. This is a very different style learning. And it's also, and again, the architecture is just more robust. I mean, it's not sitting there, and my argument here is not don't use neural networks and don't use big data. It's use neural networks and use big data to understand the surface structure of language to help you kick off a deeper interpretation, one that ultimately is logically grounded. I'll do one more. So we can take the knowledge we learned from the plant example, and this is why this notion of building a curriculum, humans learn through a curriculum. You usually learn Economics 101 before you learn Economics 102, otherwise it becomes too burdensome. So this is about Amy and her friend Jill, and they love wine, and they each bought a case of Pinot Noir. You see there's a similar theme going on in the story where Jill puts her wine in a controlled refrigerator to maintain its taste. And immediately it says, do you agree Amy and Jill buy the cases of wine because they like wine? And it's basically using the knowledge it just learned. I like to basically when people buy things because they like properties of it. So I'm going to say yes. And so as it's reading this, it's putting this stuff together. It makes sense to me that Amy moves her bottles into the refrigerator if the refrigerator is cold and dark. I think the refrigerator is cold, but I don't know about dark. Is the refrigerator dark? So here's where it's reading the story. It learns later in the story that it's important that putting the wine in the refrigerator, and the refrigerator had these properties about being cold and dark. it goes out into large corpora like the web, and it tries to learn whether or not refrigerators are in fact cold. It does. It can't learn that they're dark. People don't write refrigerators are dark, but it knows that if it had that information, it would be able to build a deductive proof that would explain the logical connections in the story. So now it's asking me, so yes, generally they are. And when it gets that information, it can start to tie that stuff together and start to say, okay, I can make sense out of this. Can I also assume that Amy wants the taste of the wine to be good? Again, you're looking at a combination of reading ahead in the story, trying to build a consistent logical model for what's going on, looking at where things are missing, and then using whatever resources it has, including talking to me, to try to tie that up and build a consistent model. It usually doesn't take this long, I don't know, but I mostly wanted to show you where I'm gonna give up here, and I'm going to. I don't know why I'm having a problem with that. I don't know why I have a problem with it. So what I'm going to do is I'm going to close because I know I'm probably late now, but I want to show you one other example of this. So let's see if I can go here, because in the event that I thought I might have internet problems. So what I did was I printed all these screens. That's so sad, but I did. And I mostly wanted to show I mostly want to show this, where as it's reading, it says, I'm trying to understand why Jill moves the bottles onto the counter. It makes sense to me if I can assume that the taste of the counter is good. So it has this knowledge that properties transfer between objects that are learned from other stories. And now it's asking, does the counter taste good? And the answer is, of course, the counter doesn't taste good. And so I let it know that. And so now it can't stitch the story together. It doesn't make sense. And it accesses the other knowledge it learned and says, well, here's a different thought. I've learned that often when a person buys a thing, they put it in their home. Is that why she put the, she ended up putting the wine on her, on the counter? And then finally, if the window has light, Jill moves the bottles to the window. Therefore, the window is light. If the wine is light, then the taste of the wine will decrease. Is that right? Yes. And we kind of get to the end of the demo. So that's the idea. So this is a very, very different sort of interaction with the machine. At EC, we call it natural learning. I'll close with the architecture picture again, just to give you a flavor. That this wasn't as simple as taking a large amount of trained data and feeding it into a machine learning system. This was involved the construction of fairly robust architecture and getting it to perform both from a reasoning perspective and from a language perspective to start to understand content and build that understanding over time is I think, the kind of AI that ultimately we need to get to a point to reach my ambitions, which is for machines to become legitimate thought partners, to be able to read, to be able to understand, and to be able to dialogue fluently with us about the knowledge it's acquired. Thank you.